Hey guys, welcome back. Today I want to talk to you about formulas for discrete random variables. In our last video, we discussed discrete random variables. So now I just want to talk to you about a few formulas. First, just a friendly reminder that e of x is really just the expected value of a variable x. Now, that could be anything from the average amount of children tickets someone purchases to a movie, or the average amount of shoes someone purchases a year, and so on. We also can have many of these, so I'm going to call this guy e of y. And this is just the expected value of y. So, if x and y are independent, that's very important. If x and y are independent, then we can do something with both of these variables. We can figure out what e of x plus y is. Well, e of x plus e of y is just e of x plus e of y. That's right, you just add them together and you get the average for the total. E of x minus y is equal to e of x minus e of y. And pretty much that's how you figure out the total or the difference of two random variables. So let's take a quick look at an example. The average SAT score on the mathematics section is 530. So I'm just going to represent that with E of math is equal to 530. While the average SAT score of the verbal section is 510. Well, if you decide to take the SATs, and we know that this is the average for the math section and the verbal section, then what is the expected total score on the, what's the expected total score on the SAT? If we know that when a student earns, what a student earns on the math section is not influenced by what the student will earn on the verbal section. In other words, these two events are independent. Typically, they are dependent. Someone who scores well on the math will also score well on the English, but let's just assume that they are independent. The two events, math and verbal, are independent. What is the total? Well, the total score is just going to be the sum of these two, and that's how easy it is. So it's going to be the expected math plus the expected verbal, and you'll just get 530 plus 510, and that's going to give you 1,040. So that's pretty much how you find the total. In this case here, I said the average height of adult males is 68 inches, and now this time I'm just going to represent it a little bit different than e of x. I'm just going to say mu of x, or I'm actually going to change that if you don't mind. I'm going to change it to males. So let's start again. Mu of m is 68 inches. And the average height of adult females is 66 inches. So we're going to call this F. What is the average difference, male minus female, if we know that the male and female are independent from one another? So these two, male and female, they're not brothers and sisters, they're not related to each other, because that can probably skew some of the data. So we want to make sure these two have nothing in common. So they're independent from one another. What is the difference? And notice how I put male minus female. So e of x minus y is the same as mu of x minus y. I wanted to denote it in both ways because depending on the problem, some books use this way, some books use this way. But this is just, maybe I'll just write that right below. This is just e of x minus y, which is e of x minus e of y, or mu of x minus y is just mu of x minus mu of y. They both mean exactly the same thing. And that answer is pretty simple. It's just going to be 68 minus 66. It just shows a difference of 2. Now notice I put male minus female. If I put female minus male, you would have to put the 66 minus 68. So that's how we do the addition and subtraction of averages for discrete random variables. Coming back here, I just wanted to add two more formulas, which is actually just going to be one formula. The variance of x plus y is equal to the sum of the variance of the x and the y. And the variance of x minus y is actually, and I'm not making a mistake here, is actually the sum as well. Now this has to do with standard deviation, and standard deviation being the distance, and distance is always positive, and there's multiple ways of showing that this is still plus. So you're just gonna have to accept it from me. I'm not lying about it. Make sure that this is the most important formula, because a lot of students like to put the subtraction sign here, but it's not, it's an addition. And then obviously if we take the square root of this guy, we will get the standard deviation. Now, this here, obviously we can't separate that. That's not legal mathematically. So the variance, if we take the square root, we get the standard deviation. And remember, standard deviation is the spread. So let's try a problem really quickly. Men at a certain workplace make an average. So I'm going to call it, I'll actually use both of these notations, $78,000, while women make an average of $70,000 at the same place. What is the difference in salary if we know that men and women are independent? That's key, guys. Well, the difference in salary, I didn't tell you which way, but I would prefer the higher number. So we're going to go males minus, or men minus women. So that's just men minus women, the expected values. That's just going to be $8,000. And what that means basically is on average that men make $8,000 more than women at this specific workplace. Now, I've only used two variables, x and y, but you can use as many variables as you want. For example, the amount of money a family spends a month on certain, let's say, utilities and rent and groceries and so on. I wanted to actually put groceries to be $100 here, pardon. So we say that a family spends on average a month $100 on groceries and $30 on gas and $60 on electricity and $1,500 on rent. Now, what we notice here is that not every month a family will spend exactly $100. It fluctuates. So when it fluctuates, we say that there's some sort of standard deviation. It deviates by $30 or $10 or $15 or no dollars. Notice how I put $0 for rent. Rent is pretty much stable. It doesn't change month to month. So if you pay $1,500 a month, probably the standard deviation is going to be 0. So let's figure out our total bill for the month. And obviously there's more items, but we're just going to pretend that these are our only items. So it would be the groceries plus the electricity plus the gas plus the rent. And so that is going to be 100 plus 60 plus 30 plus 1,500. Now, you can extend this as much as you want. And so we have 190, and so we have 1,690 is their monthly bill. But this part right here is the most important part. The standard deviation. You're going to have to square all of the standard deviations first. And I'm going to just put the 0 there. And once we figure that out. That's going to be 900 plus 100 plus 225 plus 0. That looks like it's going to be 1225. And so this is still squared. So this is the variance. So the square root of 1225 is 35, I believe. Yes, it is. So the standard deviation is 35. So what this typically means is that you're going to spend an average of $1,690, give or take $35, $70, or $105. I did that 3 times because there's something special about that number 3. We can typically go 3 standard deviations away from the mean in either direction. But that's not for this video. So that's how you find it. You're going to have to square everything, add them up, and then take the square root of them. Our final example, let's get rid of this color. I'm not a fan. I'm not a fan of that color either. Let's say the amount of clothing a person purchases. Let's say every year, on average, someone buys 3 shoes, 7 pants, 10 shirts. But it fluctuates. So you don't only buy 3 shoes. You may buy plus or minus 1 shoe, plus or minus 3 pants, plus or minus 5 shirts. The total number of items purchased per year would just be the shoes, the pants, and the shirts. And all you would do is 3 plus 7 plus 10. So typically a person purchases 20 items. Once again, the standard deviation is the most important. First, bring everything to a variance. So we want the square of the shoes, the square of the pants, and the square of the shirts. And then we just add them up, and that looks like it's going to be 35. And so the standard deviation of the item is going to be the square root of 35. Well, we know the square root of 36 is 6. So this is about to be 5.9. I'm just making that number up, but it seems like it's 5.99. So once again, the most important part of all of this is going to be these formulas. Remind yourself that no matter what, whether it's plus or minus, that you're always adding. Hope you guys enjoyed. Stay tuned for the next video.